So I know for lesson 6.4 for this homework, I'm asking you to set these up and write these like proofs. And I know I'm getting some messages over the weekend that kids are confused. So I'm going to go through what I would be expecting here. So for number 7, and the directions actually say side angle side similarity theorem. Determine whether the two triangles are similar. If they are similar, write a similarity statement and find the scale factor of triangle B, triangle A. What I said I wanted you to do was look at these drawings, see if they were similar, and write it like a proof. So, my first step is going to be that angle D is congruent to angle W, because they're both right angles, and right angle congruence theorem says they're both congruent. Now, this triangle, I actually need to turn it around to have it orientate and line up. So I'm going to make that the right angle. The right angle is angle D. D to E is the shorter side, so I'm going to lay that there because the shorter leg is on the bottom in this other triangle. The longer leg is to the right side of the triangle, has measure of 15. So in order for these triangles to be similar, I would need ED correspond to YW to have the same ratio of sides as DF would have to XW. And I'm going to fill in these numbers. ED has a length of 9. YW has a length of 6. This side, DF, has a length of 15. WX has a length of 10. 9 over 6 simplifies to 3 over 2. 15 over 10 simplifies to 3 over 2. So I have here 2 sets of corresponding side ratios are equal. So 2 sets of corresponding side ratios are equal. So I can prove that these triangles are similar by the side angle side, put this over here, side angle side similarity theorem. And I prove triangle EDF is similar to triangle YWX. If you put the letters in different orders, that's fine. They just have to correspond. D corresponds with W. E corresponds with Y. F corresponds with X. So now I'm going to clear my annotations, and I'm going to do the same thing with this triangle here. And I am going to orientate, I'm actually going to orientate the bottom one. I'm going to reorientate that. So that is L is going to be the 112-degree angle. The shorter side is going to be LK with a length of 10. And the longer side is going to be LJ with a length of 24. So I have that angle T is congruent to angle L. Basically, that's given to me. They're both 112 degrees. Now, for these to be congruent, I need the corresponding side length of ST, which is going to correspond to the side length of LK, to be the same ratio as RT to JL, which means I need 8 over 10 to correspond to 18 over 24. So I'm going to simplify this. 8 and 10, they're both divisible by 2. That's 4/5. 18 over 24 simplifies, they're both divisible by 6, so it simplifies to 18 divided by 6 is 3/4. Those are not the same ratio, so not similar, because the two corresponding side ratios are not equal. Okay? Or actually that would say are not equal, are not equal. So number 8, they are not similar. Draw another rectangle here. And go on to number 10. Now number 10, I actually did number 10 in most of the classes yesterday. But basically I'm going to have two triangles. This is H, G, J, and this is H, F, K. So this is 15, this is 20, this is 18, this is 24, this is 16.5, and this is 22. So for this one, I'm actually going to do this one right now by side, angle, side. Because angle H is congruent to angle H. Is congruent to angle H by the reflexive property of congruence. Now my two sets of corresponding sides have to be the side lengths that make up, the sides that make up that included angle. So I'm talking about HG corresponding to HF and HJ corresponding to HK. I am not using GJ and FK because those are not the side lengths involved in the included angle. So HG is 15, HF is 20, HJ is 16.5, 15 over 20 is 3/4. If you're not sure because of that decimal in the 16.5 over 22, you can actually in the calculator do 16.5 divided by 22, and that equals 0.75, which is 3/4. And the real math way to do that, to clear that decimal, is 165 over 220, and then start simplifying. 165 divided by 5 is 33. And 220 divided by 5 is 44. And 33 and 44 divided by 11 are both 3/4. That's the real way to deal with the fraction if you did not have a calculator. Although I had a calculator here to simplify. Moral of the story, triangle HGJ is similar to triangle HFK by side, angle, side. In class yesterday, I know in 3rd, 4th, and 5th period, I'm not sure about 2nd period. I know I did not do this one in 1st period. I also did these by setting up the side ratios. This was 15, this was 20, this is 18, this is 24, this is 16.5, this is 22, and I set up all of the side ratios. So 15 over 20, 18 over 24, 16.5 over 22, all equaled 3/4. So my reason for number 1 was I had 3 sets of corresponding side ratios are equal. And then for step 2, triangle HGJ is similar to triangle HFK. And in this case, it was side, 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 similarity postulate. So I could do that one either way. For number 11, delete those. So for number 11, when you see these crisscross lines, you should be seeing that you have a set of vertical angles. And vertical angles are always going to be congruent. Now, when you're talking about vertical angles, you need to use the angle symbol. And in this case, you cannot just say angle C is congruent to angle C because there's a number of angles C. So you actually need to say angle ACB is congruent to angle ECD. Since C is the vertex of both of these angles, it needs to be in the middle. Number one place, I still see students messing up vertical angles congruence theorem. They know that they're vertical angles. They label them. I can see you labeling them on your work. You write vertical angle congruence theorem, but this statement, you use only 2 letters for angles, or you use a line segment symbol instead of an angle symbol. So that's the number one place you mess that up. Make sure you don't do that anymore. Now, 2 sets of corresponding sides. It's sometimes difficult to tell which one is going to correspond with what. So what I suggest you do is the shorter one that's labeled here, which is CE, is going to correspond to the shorter labeled side here. The longer one on the first triangle, CD, is going to correspond to the longer one on the second triangle. So let's see here. CE is 14. CB is 21. CD is 18. AC is 27. 14 and 21 are both divisible by 7. 14 divided by 7 is 2. 21 divided by 7 is 3. 18 and 27 are both divisible by 9. 18 divided by 9 is 2. 27 divided by 9 is 3. So these are both simplified to 2/3. That means I have 2 sets of corresponding side lengths ratios. Actually, I shouldn't have said corresponding side length ratios. Corresponding side ratios are equal. That means triangle ACB is similar. Don't mess these up. A is corresponding to DCE. And that's side, angle, side, similarity. The 2 sets of corresponding sides and their included angle. And to make sure you put this in order, A and C are the longer labeled side length here. They correspond to D and C, the longer labeled side length here. C needs to be in the middle because it is the included angle. And let's look at the last one. We know that angle X is congruent to angle D. That's given. And in this case, we can use only one letter because there is only one angle X and there is only one angle D. Now I would need my corresponding side ratios to be congruent. So XY is the shorter labeled side over JD is the shorter labeled side in the larger triangle. That needs to correspond to XZ, which is the longer labeled side in the smaller triangle, would correspond to GD, which is the longer labeled side in the larger triangle. So 21 over 35 would have to be equal to 30 over 50. 30 over 50 simplifies, that's one's easy, to 3/5. 21 and 35 are both divisible by 7. 21 divided by 7 is 3. 35 divided by 7 is 5. So they are the same ratio. So corresponding side ratios are equal, and actually it's two sets. Corresponding side ratios are equal. So triangle ZXY, you could put these in different words, but that's how I'm doing it, is similar to Z is on the longer labeled side, so it's going to correspond to G. D is the angle that corresponds to angle X, J, and the reason is side, angle, side, similarity theorem. So I hope that explains to you, walks you through, obviously, how to do the homework and how to write these out in the way I would want you to write them out.